Hi, I'm Pete and I work on Dagster. Today I'm going to take you through the process of taking an existing ETL script written in Python and bringing it into Dagster's Software-Defined Assets framework. This is actually a pretty simple process, and it provides a lot of benefits over just kind of creating a normal ETL script that's very imperative. So let's get started. The first thing I'm going to do is open up a new Python environment with this thing called Gitpod. It's a very convenient way for us to all get a single consistent Python environment. So I recommend going through this example tutorial using Gitpod, but you can use your own Python environment. Gitpod just makes sure that you're using exactly the same tools and Python environment that I am. So let's start by creating our ETL script. Whoops. So what we're going to do is we're going to create an ETL script that extracts a bunch of data from the Hacker News API, basically the titles of the top 500 Hacker News stories, and then creates a word cloud, puts that word cloud into a markdown document, and then saves that markdown document to disk. So this is a classic example of an extract, transform, and load process, an ETL process. So we're extracting data from Hacker News, we're transforming it into a word cloud embedded in a markdown document, and then we are loading it into the file system where it can be used by other people. So let's start with a bunch of imports into our ETL script. These are largely kind of like built-in Python packages or matplotlib for plotting the word cloud. There's a word cloud package, requests and pandas for fetching data from the Hacker News API, and this TQDM library for rendering a progress bar. Next, let's write a function for extracting our data. So this is our extract step. It can be a little bit hard to see here, so I'll close that. So we hit the Hacker News API to extract the IDs of the top 500 stories. Then for each of those stories, we go through and we hit the Hacker News API to fetch metadata about that story. So its title, its description, comments, etc. We put all that into a data frame and then we return it. So that is our extract step. We've put that into a Python function. The next thing we're going to do is we're going to create a transform step. So this is our transform step. We're going to take in the Hacker News top stories data frame from the previous step, and we're going to transform it into a word cloud embedded in a markdown document. So we strip out some common words that we don't want to appear in the word cloud. Then we go through each Hacker News story, and we split the title into a set of words, and then we take those words and we put them into the word cloud. Finally, we position the word cloud within an image. We save that word cloud as a PNG file in memory, and we take those PNG bytes and we embed it directly into the markdown file. So that uses base64 encoded images, if you're curious. Finally, we need to have a load step. So this load step takes in that markdown text from the previous transform step, and then it will write a file called output.md onto the file system containing that data. So putting it all together, we have our extract step, our transform step, and our load step. Now before we can actually run this, I do need to install some dependencies here. So I need to install matplotlib, requests, pandas, word cloud, and TQDM. That'll take just a second. And now that we're all installed, we should be able to run this. And I'm just gonna, as you can see, there's a progress bar that's going now down here. As we go through every one of the top 500 stories, we're hitting the Hacker News API, we're downloading that data. And so this is showing us our progress. And you can see it's going to take about a minute for that process to complete. Now, there are a bunch of problems with having this as an ETL script in Python, as just a regular Python script. So first of all, this process takes a while. It would be great if we could iterate on different parts of this pipeline without rerunning the whole thing every time. So for example, if I want to change the color of the word cloud or how it's rendered or the different set of stop words that go into it, I have to rerun my whole Python script, and that will have to run this expensive process of downloading all this Hacker News data every single time. So it would be great if we didn't have to do that. The second problem is that we're issuing 500 or more requests to an external system. Those requests could be slow, or they could even fail. And so how do we deal with this pipeline failing? How can we make sure that it's robust? How can we retry the pipeline when it fails? The third problem is that in a complex pipeline, this loading code could be fairly complex. And if I wanted to store this in a different place, so for example, rather than on the local file system, I want to put it in S3 or in a Git repo somewhere. This would require kind of making manual code changes to the innards of this project. So that is, there's a number of things wrong with this. And finally, there's nothing in here about scheduling. So with a pipeline like this, we generally want to run it on a regular basis so this word cloud stays relatively up to date. And we wanted to kind of make sure that we understand what that schedule is and make sure that our stakeholders are aligned with it. So this is where all these problems can be solved with an orchestrator, and we think that Dagster is a really exciting way to do that because of its notion of software-defined assets, which really maps extremely well onto this kind of ETL paradigm. So the first thing I'm going to do here is I'm going to install Dagster. Well, actually, before we do that, let's take a look at the output of our pipeline. So you can see here there's a bunch of markdown data, and if we open the preview over here, we can see our little word cloud. Twitter seems to be a popular topic today, so that's exciting. So let's port this over to Dagster Software-Defined Assets. So the first thing we need to do is install two packages. One is called Dagster, and the other one is called Dagit. Dagit is the user interface for Dagster. We'll be using that a lot. So we'll create a new file called hndagster.py, and this is going to be the Dagsterized version of this script. So the first, and one strategy that you can use to get started really quickly is to just wrap your whole script in a software-defined asset. And that actually isn't super hacky because the output of this ETL pipeline is what we call an asset. An asset can be a report, a table, an ML model. In our case, it's the word cloud embedded in the markdown document. And we could kind of squint and call that a report. And so let's just wrap our whole script in a software-defined asset. So I'll show you how to do that. So we first want to import our code from Hacker News. So from Hacker News, import, extract, transform, and load. And then we want to import the asset decorator from Dagster. And we say, hey, we've got a an asset called Hacker News Word Cloud. And we can just copy and paste our code from our script and just paste it right in here. And it's really that simple. Now your entire existing ETL pipeline is running within Dagster. And I can spin up the Dagster UI. So I write dagit-f hndagster.py. That says run the Dagster UI and point it at this Python file. That's what the -f means. Then I can open the browser. And we're already realizing the benefits of an orchestrator right now. So rather than having to have stakeholders run a shell command, now you have a user interface where you can see, hey, this has never been materialized before. You get a nice button where you can click the button rather than run a shell command. And you get a nice little UI where you can watch this thing execute. And I can, in fact, even go see the progress bar being printed down here. So I just want to, as this executes, give you like a little bit of a tour here. So we have a list of all of our assets. You could imagine bringing multiple ETL pipelines in here and having them all listed out here. You can see the last time they ran. You can see the last time they were materialized. And over time, you can see kind of the history of each one of these materializations. So already the orchestrator is helping you keep track of everything that's going on in your ETL process. And I can see what's happening in real time. So this helps both you kind of keep track of stuff as well as your team collaborate on these types of things. So as you can see, our ETL process is done. This is marked as successful. And if we just refresh over here, you can see the last time this asset was materialized. So this is already very useful metadata for you to keep track of. However, let's talk about some of the problems that we faced when we were kind of building this original Python script. The first thing that I mentioned was dealing with failure. So let's see what happens if we introduce failure into this process. So I can say raise runtime error fake failure. So this is just an example of introducing an exception. In a real project, this would be one of these HTTP requests failing. So if I click this reload definitions button, we'll have reloaded the code, and then I can rerun this, and you will see it fail. So you can see that the process has failed. And if we go back over here, or go over to our assets view, you can see that this asset has been marked as failed in our UI. So Dagster tells us when something's working and when something isn't. Let's try to make it robust. So Dagster offers a number of capabilities to make your pipelines more robust, and one of the most important ones is called retry policies. So I can import retry policy, and I can say, my retry policy is going to be max retries 5. So we're telling Dagster, hey, when my pipeline fails, retry it up to 5 times, and then wait 5 seconds in between each retry. So if I were to then reload these definitions, and then I hit materialize, we've launched another run, and you can see the pipeline failed, and then it's restarting again automatically. So in situations where your pipeline has intermittent failures, Dagster can keep track of that and retry it a number of different times until it hits the maximum number of retries, which we put as 5. And then when it hits that maximum number of retries, it will fail the whole run. And so you can see that failure in the dashboard. Should stop right after this. Yep, so the whole thing failed, and you can see it failed. So this is a great way to make your pipelines more robust. The next problem that we had to solve with Dagster was, or the next problem that we had with our Python script was scheduling, right? So we want to run our pipeline, let's say every 30 minutes or so, just to make sure that this report is always up to date for our stakeholders. So Dagster's got a feature called declarative scheduling. Specifically, the object it uses is called a freshness policy. And this lets you declaratively say, hey, I want this asset to be updated to always be 30 minutes or less lagged from reality. So I can say, create a freshness policy, maximum lag minutes equals 30. And what this does is it tells Dagster to automatically run, if we deployed this to production, Dagster would automatically run it, every 30 minutes to make sure that the data is up to date. And it can warn you when the data is not up to date. So if I were to refresh these definitions, you can see now we've got this new thing over here called freshness policy. It says, at any point in time, this asset should incorporate all data up to 0.5 hours before that time. And when this data gets stale, it will warn you about it. Dagster will automatically rerun it for you. You don't have to think about anything. You don't have to think about a specific time of day to schedule your ETL pipeline anymore. Just let Dagster figure it out. Now, in simple ETL pipelines, declarative scheduling might not seem like that big of a deal. But when these pipelines can get really complex and all depend on each other, this actually really saves you a lot of time and effort as a data engineer. So just recapping what we've done so far with really just, let me show you this full code here. We've basically just copied and pasted our existing script in here. And then we've added 2 little configuration lines here to specify a retry policy and a freshness policy. And now we have scheduling taken care of for us, and we have dealing with failure taken care of for us. Now, if you recall, there was another problem that we had to solve with our Python script, which is we didn't want to rerun the script all the time. We wanted to cache the expensive operations. So if we want to iterate downstream of those, we don't have to rerun the whole script every time. So the way that Dagster deals with this is we create multiple software-defined assets. So right now we have one asset that represents our whole pipeline. Let's break it down into a couple different assets to kind of make this a little bit easier to deal with. So I'll create an asset called Hacker News Source Data. This is the expensive asset from the previous example that issues those 500 or so HTTP requests to download all the information about each Hacker News post. So this just runs our extract function. And then in here, we can reference the name of the upstream asset as an argument. And what this basically does is Dagster looks at the name of the argument and infers a dependency between these 2 functions. And so I can just say, input, rather than have input equals extract, I just transform the Hacker News source data. And now if we reload these definitions, you can see that we have split them into 2 separate steps. The first is fetching the data over the network, which is really expensive, and the second is creating that word cloud. So the idea here is that I can materialize this once and then iterate on this step separately. And what's cool about this declarative scheduling feature in Dagster is that because Hacker News Word Cloud wants to be 30 minutes or less out of date at any given time, it will automatically schedule its dependencies like this Hacker News source data to be refetched at the appropriate time too. So I'm just going to hit materialize all here, and we can watch this thing execute. It does take a little while. One thing I want to note is that we are running this in development. And so what that means is that this data is actually being downloaded and cached in this temporary folder that's created by Dagit, the user interface for Dagster. In production, you can configure this in a number of different ways. You can point it at a Postgres server, you can point it at SQLite database on disk, and you can store artifacts in S3 or a number of different places. But for this example, we're just running it locally to keep things simple. So you can see here we are almost done. And you can see that the user interface here, this is kind of like your single pane of glass for your ETL process. You can watch the execution in this view too. And so we can see here that this freshness policy is obviously consistent, and we can go and take a look at that run that had executed and see the logs of everything that happened broken down by each step. And what's really cool is I can just rematerialize this one step. So if I'm going to change how my word cloud is rendered, I just have to run that one step. So this can really increase your development velocity. All right, so we've solved almost every part of our problem here. However, one thing that we haven't solved yet is we still have that load step deeply integrated inside of our code. So if I want to change where that markdown file is stored, if I want to put it on S3 or I want to put it in a GitHub repo or something, right now, we have a pretty hard dependency on storing that in the file system. So with Dagster Software-Defined Assets, it's really easy. There's built-in features to basically separate storage from business logic. So we can write reusable business logic for things and then plug in different storage backends completely transparently. So this is very useful in a number of different situations. Number one, if you need to migrate to a new storage system, for example, moving off of your local disk to something like S3, that's really useful. It's very useful for testing. So you might want to run with one storage backend in test environment and a different one in production. And third, there's a feature of Dagster Cloud called branch deployments, where you can create branched staging environments, an unlimited number of branch staging environments for each pull request. And having this kind of separation between where things are stored and the logic that computes them is incredibly powerful. So let's take advantage of that feature here. We're going to use something called an I/O manager. So an I/O manager basically abstracts away all of the storage logic in our code. So first, we're going to import I/O manager, and then we are going to create a new I/O manager. Let me just paste it in so I don't have any typos. So I/O managers basically do two things. They save assets to disk, they save assets to storage, and then they load them from storage. For the purposes of this example, we're not going to be loading anything. We're just going to save the final result. So I'm not going to even implement the load input method. I'm just going to call our existing load function from handle output. So if you recall, we imported this from our existing script. This is the load step of extract, transform, load. All we do is we call it here in the I/O manager, and then we basically hook this asset up to that I/O manager. So we say I/O manager key equals Hacker News I/O manager. This tells our asset to use that I/O manager, and then we don't need to call this load step explicitly anymore. All we do is return the transformed data, and then the I/O manager will deal with reading and writing the data to whatever backend. So this asset now is pure business logic, which is really great for testing, and it's just really, I think, the way that engineers want to work. So you might be wondering about this string, like where did this name come from? Well, we do have to write a tiny little bit of boilerplate to hook this up. And this is pretty useful boilerplate actually, because it allows you to specify different I/O managers for different contexts. So the first thing we're going to do is just create this definitions object. This kind of packages up all of our different definitions in our project. So we want the Hacker News source data asset, and we want the Hacker News word cloud asset. And then the I/O manager is called basically, I/O managers are a type of thing called a resource. Resources have keys, so Hacker News I/O manager is going to be an instance of the Hacker News I/O manager. And so if I didn't make any mistakes and I reload my definitions, we can see that nothing has really changed. But if I go and delete this output, for example, I can go and just rematerialize this thing. We can watch the run. And the file is back. So what we've basically done here, just to recap, is we've refactored our Hacker News word cloud asset to just do the transform. And then we've used this definitions object to hook up the IO manager to this asset. Let's recap the overall thing that we've done here. We've gone from this ETL script, which is done in a very traditional, very imperative way, and with just a couple of small little refactorings. So splitting it into a couple of different software-defined assets, declaratively specifying retry policies and freshness policies, and then introducing the notion of an IO manager to extract out that load step. We've created a robust pipeline, a scheduled pipeline, one that is resilient to errors and can be iterated on very quickly because you can cache the expensive operations. And it's very easy to test too because you can simply swap out that IO manager and store the markdown file in a different place if you'd like. So overall, there's a lot of benefits to using something like Dagster instead of just a regular Python ETL script done from scratch. And it's actually not very much work to realize a lot of these benefits. So I hope that this tutorial was helpful. I had a lot of fun working on it. And just shoot me a tweet or engage with us on our Slack community if you want to learn more. Thank you very much.